Hey everybody, this is Mama Siski again. If you didn't hear from me in one of the previous videos, I am Mr. Siski's mom. And here's a picture of me and Mr. Siski's dad. So that's Mama and Papa Siski. And today the video will be about factoring a trinomial when a equals 1. And also it's going to be about Mr. Siski's hair. His facial hair, his man bun, and a super special surprise at the end. So hang on, we'll get to it. Okay, so what I meant by a trinomial when a is equal to 1 is this. So this is a trinomial because it has 3 terms. 1, 2, 3. That makes it a trinomial. This trinomial is special because, and I'm not sure if you've learned this yet, but every one of these trinomials, the coefficients are lettered. So this coefficient is A, and this one is going to be called B, and this one is called C. So in all these examples, the A will be 1. So in every example we do today, when we factor it, every problem will start out with just a plain x squared, or 1x squared. So factoring is trying to figure out what the problem looked like before we did the FOIL method. So our answer is going to be 2 binomials. In fact, when I made up this problem, I took 2 binomials and multiplied them together and wrote the answer down. So now you're going to try to figure out what binomials I started with. And to do that, we draw something called a factor x. So you're just going to draw an x. It goes from the first term to the last term. And the 5 is going to drop all the way down to the bottom. And then to get this part of the x, we are going to multiply 1 times 6, which is 6. And the reason I multiplied the 1 was because right here my a is 1. So that's how you set up the factor x. Now you have to try to figure out what 2 numbers would go here and here. And it can't be just any numbers. It has to be 2 numbers that will multiply to give 6 and add to give 5. So if you're really good at your multiplication tables, you can probably just come up with that in your head. If not, start writing down 1 times 6. That's going to be 6. Do those numbers add up to 5? No, that adds up to 7. So then try 2 times 3. Does that multiply to give 6? Yes. Does it add to be 5? Yes. So the numbers are 2 and 3. And it doesn't matter whether you put the 2 here and the 3 here or vice versa. And I'll show you what that will look like later. Once you finish making your factor x, you bring down your x squared. And then you bring down a 2, positive 2x, and a positive 3x. And now the positive 6. So let's talk about why that was important. When you were doing the FOIL method, when you first multiplied something, you had 4 terms that you combined. Well, that's what just happened here. That x, factor x that we did, helped us come up with the 2 middle terms that were getting combined. So now I'm going to combine those middle terms. 2x plus 3x is 5x plus 6. That will help me mentally check to make sure I did that right. Okay, now to get the answer to this, we're trying to figure out what it looked like before the binomial was multiplied together. So I'm going to end up with 2 sets of parentheses. That's going to be my answer. To get those 2 sets of parentheses, we're going to factor. So I'm just going to look at the first 2 terms. This is called factoring by grouping. I'm going to look at those first 2 terms, and I notice that they both have an x in common. So I'm going to factor out that x. When I factor out the x, I know that when I multiply these together, I'm supposed to get x squared, so there had to be an x here. And when I multiply these together, I'm supposed to get 2x, so there has to be a 2 there. This is the way I explained it. You can also think of it as dividing. Like I had to divide x squared by x, and that gave me x. I had to divide 2x by x, and that gave me 2. Now I'm just going to look at the second group of numbers, the 3x plus 6. And I notice that they have a common factor of 3. In fact, it's a positive 3, so I'm going to put a plus 3 there. And whenever I factor this, I'm going to know that if I divide 3x by 3, I get x. In other words, When I multiply 3 times x, I'm going to get 3x. When I divide 6 by 3, I get 2. Or you're thinking about 3 times what would give me 6. Now I notice that both of these, the parts of the problem, have another common factor, x plus 2. And if I factor out x plus 2, out of the first group of numbers, I'm going to get an x that's left over. That's this x right here that I'm talking about. And if I factor out x plus 2 out of the second side, I have a plus 3. So there's the answer that I got when I factored this trinomial. It's the problem that I started with before I FOILed it, if that makes sense. I'm going to go through this again quickly without all of the boxes and arrows so that you can kind of understand what the problem looks like as you're working it. So the first thing I'm going to do for our trinomial needs to be factored, and the a is 1, so I'm going to draw my factor x. Bring down the 5. I'm technically multiplying that 1 that's right there times 6 and getting 6. And now I'm trying to find two numbers that multiply to give 6 and add to give 5. Now, earlier I put the 2 first. If I put the 3 first, that's okay. We're still going to get the same answer. It's just going to be that my parentheses are going to be reversed. So if Mr. Siskey says that the answer is x plus 2, x plus 3, and you have x plus 3 and x plus 2 as your answer, those are the same thing. Okay, now that I've got my factor x complete, I bring down my x squared plus, and this comes from the factor x, 3x plus 2x plus 6. Now I'm going to factor these. They have an x in common. When I factor that x out, or divide it out, I get x plus 3. Over here I notice that they're both divisible by 2, so 2 is going to be my greatest common factor. When I factor out a 2, I get x plus 3. Now I have another greatest common factor. So before I looked at these two, if you see my brackets there, those two separately to see what they had in common. Now I'm going to see that these two have in common an x plus 3. And if I factor out that x plus 3, I'm left with x plus 2. So that's the answer. That's what the problem was before we FOILed it. And to check your answer, you can always do the FOIL method, see if you get x squared plus 5x plus 6. Okay, so here's our first sneak peek into Mr. Siskey's hair journey. Okay, this was some of these pictures before he even had facial hair. You can see that his hair was shorter then, as opposed to the next slide that I show you after the next problem, where it was a little bit longer. But these were probably, the first picture is probably around his senior year. Second picture, I think, was probably his sophomore year of college. And I think the other two were probably in college as well. In the last picture, I want to say that maybe he was a lifeguard then. I'm not real sure. But anyway, so this is what Mr. Siskey looked like back in the day. Okay, for our next problem. Again, we have a trinomial. The a is 1. So we're going to draw a factor x. We're going to bring down the 2. We're going to multiply the 1 times negative 15. Now notice that I said negative 15. That minus made the 15 negative. And we're going to try to find two numbers that multiply to give negative 15 and add to give 2. And to make this video just a little bit shorter, I didn't do my guess and check method off to the side, but if you're struggling with two numbers that multiply to give negative 15, make a list of numbers that multiply to give negative 15 and then check them and see which ones add up to be a positive 2. Okay, the two numbers that multiply to give negative 15 and add to give a positive 2 are 5 and negative 3. So once I fill in my factor x, I bring down my x squared, or 1x squared, plus 5x minus 3x and minus 15. Don't forget to carry these signs down. The only thing that's optional here is this 1. You don't have to have the 1 there, but you do need to bring down, since this was a positive 5, a plus 5x, since this was a negative 3, a minus 3x, since this was a negative 15, bring down a minus 15. And now we're going to factor by grouping. We're going to look at these two and notice that they both have an x in common. And if I factor out the x, I get x plus 5. On the other side, and this is where it gets tricky, I'm going to factor out a negative 3 because it was a minus 3. Whenever I'm factoring this out, I need to make sure that I'm watching my signs. And this is a good one that you would probably want to go back and check the FOIL method to make sure that you end up getting, for your answer at the end, the two binomials will multiply back together to give you the original problem. All right, so when I factor out a negative 3 from negative 3x, I get just an x. Over here, when I take negative 3, and I'm trying to think of negative 3 times what gave me negative 15, or negative 15 divided by negative 3, that's a positive 5. And that's where it's going to be really hard to watch what your signs are doing there. And now I've noticed that both of these terms have an x plus 5 in common. And when I factor out that x plus 5, I get x minus 3. So here's the answer. If the directions say factor this trinomial, that's the answer. To make sure that it's the right answer and that you have your signs correct, it's not a bad idea to check using the FOIL method to see if you get 1x squared plus 2x minus 15. Okay, next on Mr. Siski's hair journey is when he was growing his hair out. Most of the time when his hair was long, he kept it under a hat or under a toboggan, like a, I don't know, kind of hid it, I guess. Didn't leave it down very much. Most of the time it was up in a bun. So you've seen that first picture, Katie's putting his hair in a bun. Second picture, he has his hair in a bun. Occasionally, he would have his hair out of the bun. And that's what you see on the third picture. And the fourth picture is Mr. Siski with his long hair. Okay, bear with me through this last problem. I promise it'll be worth it on the next screen. So, here's a trinomial. The A is 1. I'm going to make my factor x. When I'm bringing down the middle term, I'm bringing down the negative 6. That minus 6x made that term that I'm bringing down negative. Multiplying the 1 times the 8, that's giving me 8. I'm going to try to find two numbers that multiply to give 8 and add to give negative 6. Those two numbers are negative 4 and negative 2. Again, it doesn't matter where you put these, as long as you have a negative 4 and a negative 2. You could put negative 2 first and then negative 4. And the only thing that could happen is that your answer might be in reverse of the answer key. So now I'm going to bring down my 1x squared minus 4x minus 2x plus 8. And I'm factoring by grouping. I notice that these terms have an x in common. When I factor out the x, I'm left with x minus 4. And then a kind of a hint to see if you're doing this right also is that my next set of parentheses, if this works right, should be x minus 4. So if that's not working out, you've done something with your signs are wrong. And now I'm going to factor out a negative 2. When I have negative 2x divided by negative 2, I get a positive x. When I divide this positive 8 by negative 2, I get negative 4. So again, those parentheses match, and they should. In every problem, it should match. Because that's what I'm going to factor out now. The x plus 4 that they had in common, and then the x minus 2. Again, if you had your factor x had the negative 2 here, and then the negative 4, your answer is going to be the same thing. It's just going to be in reverse. You're going to have minus 2 first, and then minus 4. Now for the grand finale of the pictures. And I didn't get permission to do this. I'm just going to beg for forgiveness. And I'm going to play a little bit of stupidity. I'm going to act like I don't know who's in this next picture. But I'm pretty sure you know both of these people. Take a good look. And bye.